So for the second part of the question, which was about finding the height of the lighthouse, it says find the height of the lighthouse. How can we find the height of the lighthouse? Assume, for example, you are lying down at A and you are looking specifically along the water to the base of the lighthouse. How much higher, how much more do you need to elevate your head to be able to see directly to the top? And it tells you, it says the angle of elevation is exactly 27 degrees. That's how much higher you need to lift your head. Assuming, and bear with me with this concept, assuming you're lying down, you're at the ground, you're at point A, you're looking straight ahead at the lighthouse, how much higher do you need to raise that head of yours? And so if you need to raise your head up by a specific amount, and that amount in here is the amount that you need to do that to, and it seems to me that it's about 27 degrees. 27 degrees is how much higher you need to do that. We know what AL is, we just worked that out. AL is 100 times sine 54 over sine 56, which is around 97.6 meters. So 97.6 meters, about an athletics track in terms of the 100-meter sprint part. And so that's there, what you're having to look at, and then you need to raise your head about an extra 27 degrees. So you need to raise your head upwards in order to be able to see the top of that lighthouse. So you have to raise your head up by about that much. Now, in so raising up like that, what actually happens? Well, first of all, we know that we have the triangle here. We've got a right angle triangle. Let's say this, if you bear with me, we had enough of the arrows for a second. I need a straight line there. And if I were to perhaps be able to depict the right angleness, for want of a better phrase, in there it is. So there's a right angle triangle. And this would be described for this side here. If you get to the middle of this angle, imagine you're moving across, you look straight across to find the opposite. We know therefore that this side is actually the opposite of that angle. This long line here is going to be the adjacent. Little a we'll use. We will not allow for little a today. It'll be adjacent of that circumstance. Finally, the hypotenuse, the largest line, of course, will be up here. Now, there's many mechanisms to do this, but the quickest one is that we are aware of A. We are aware that this is the opposite, which is what we want, and we are aware we have 27 degrees. I'm going to use tan theta from SOHCAHTOA. The TOA part, tan theta is opposite divided by adjacent. Tan theta is opposite divided by adjacent, but this opposite we can call height. So I'm going to use capital H to describe that. I'm saying this is capital H in this problem because it's technically the height of the lighthouse. Also, the adjacent, again, just out of what I tend to do, let's call this X because it's what we want. So I'm going to say that it's tan theta is the height divided by what we want, which is X. Finally, what is X? Well, we've stated in the past that X is 100 sine 54 over sine 56. I can put that in there. I can also make us aware that we know how much we need to elevate ourselves to see the height, which is 27 degrees. So I can put that 27 degrees in. A little bit of calculation leaves us to 49.72 meters high is the height. This would be to 2 decimal places or perhaps 4 significant figures. This is the height of the lighthouse, and that's one way in which we are able to calculate it. Thank you.